as I was saying, the original idea of this topic, when I first started to think about the topic of this talk, it was a long time ago, maybe a couple of years ago, and we were having some beers and some discussions with some former colleagues, and I was seeing that some of them were suffering a little bit because they were forced to follow some practices and some blueprints just because the project that they were joining had this a certain particular architecture that they had to follow, even though from the very beginning they were building something small initially, but they also were told that probably that application will have to grow and scale at some point. And in order to be prepared for that, they started to do the things in a certain way, just because they read that this is the regular way to do that nowadays. So I'm going to confess something with you, because the first idea for the title that I had for this talk wasn't this. The first idea for this for the title of this talk was "Don't let the microservices hype ruin your project." But don't get me wrong, and this is one of the reasons. This is maybe the main takeaway that you could get from this session. But don't get me wrong, this is not a rant about microservices. Microservices are useful. Microservices are something that may be the right way of doing things in certain projects, but sometimes they are not. The problem is not about the microservices itself, it's about how do we consider the microservices. If they are just a goal and we need to enforce those from the very beginning, or they are just a result of doing the things in a certain way so that we could be prepared to scale. So I'm going to, in this session, what we are going to do is we are going to try to put ourselves in the boots of these developers that are joining a new project. Let's say that, for example, on Monday, when you return to your office, your manager comes and says, "Hey, you are going to join a new project, and in this project, there's nothing; it's brand new, and we need to start designing everything from scratch." Or, well, maybe that's not probably what is going to happen, but probably you are going to still be in the same project or join a new project that has already done something, but you need to implement a new feature or a particular module that is going to be new. And of course, because you have been in a conference like this, you have lots of new ideas and you have lots of new knowledge that you and that will make this project better, because this time, of course, we want always to improve, and we are going to do the things better than we did before in order to avoid the problems that we could have had before. But we also are told that in this case, because our project is going to be really successful, we need to be prepared to scale, and we need to be ready to deploy the project at some point in the future in the cloud, and maybe be elastic, and maybe be able to dimension certain parts of our application in different ways. So if you are presented with these requirements, probably you will start, and if you don't know nothing about how to do that, probably the first thing that you are going to do is you are going to open your browser and you are going to do a search in Google, looking for how others solve this exactly problem. And the more you look for different scalable applications or architectures or solutions, the more that concrete and a specific name appears on your screen. And this name is the microservices architecture. And once that you start digging into the concept, you are starting to learn that microservices architecture basically means that you are going to split your application in different modules, small modules if possible, and those modules are going to be independent. Maybe you also read that these modules could be developed, they will be focused on just a couple of features, and maybe will be assigned to different teams, and maybe even those different teams could decide to use different languages, or maybe they could just decide to have different release cadences, and deploy on different days and these kind of things. But also at the same time, when you start developing these small modules, at some point you realize that in order not to repeat yourself, some of these modules are going to require to call another modules. They will have dependencies between them. A module will probably have to request some data from another module, and that other module will probably rely on the features that another module is implementing. And soon, after realizing this, you will start thinking on how you are going to design these contracts, these interactions, and probably how you are going to either design between those modules or the way that they are going to interact. But also, at some point, you will face the situations that certain module requires some other features from another module, and then you need to hold the deployment of your feature until that other module has finished another feature that you require. So in this moment, you will realize that you need to draw the chains of dependencies between all these microservices or all these modules in order to have a global picture of how your application is working. And at some point, you will need to track and follow that chain. And that's what my 2 years old son did some time ago. And here is him trying to follow the dependencies between some microservices. And him, you will probably in this case end up with all these challenges around your neck and having the feeling that all what you have is really a little bit messy. So what was the problem? Because when you Googling about these kind of architectures, you saw that this was exactly the kind of architectures that made other systems really successful. And the problem was that we may was we may have been looking at the final solution, but when all the different paths, the different things that first try before they reach to the final solution, to the final architecture. And this is one of the problems that comes from an initial technique, but in my opinion is not so good, that I call HDD. HDD stands for hype-driven development. Really follow the other have follow in the hope that we will arrive to the same situation, to the same successful situation. But if we only pay attention to the final result, we will probably not be so successful. And this is basically because once that we have enough information about a problem, it's easy to see which is the solution. If we can see the bird's eye view of a maze, of a puzzle, we will probably have very clear idea on which was the correct solution to that. But when we start a new project, all we see is just the entrance, the start of this maze. We don't usually have enough information or context. We only have just a set of requirements, a set of features that we need to implement for our system, but we probably don't know enough about what the users or the customers really mean and want from these features. So the best approach here is just to try to consider ourselves like Jon Snow, like we don't know nothing about the problem to solve. I had a teacher, professor at the university, that used to say that the worst thing that may happen to us as developers, we are assigned a problem that we think we know about. For example, in that case, there was a particular case in which he created an assignment to model the entity relationship diagram of a football tournament. And what he said to us, and he was right, is the of you that are already participating, organizing, or watching, following football tournaments will probably the ones that will score worse assignment. Because in the moment that you see that is about something that already are involved with, like a football tournament, you will probably start making a lot of assumptions based on your particular experience. And those assumptions will probably not be the same that I'm putting in my requirement. So what we need to do basically is what we are going to do this session, this is the thing or the starting point for us, is let's try to avoid making any assumptions, and let's try to follow the practices that will allow us to discover all the information and evolve our application in a way that we are not trying to split the different modules from the very beginning based on our assumptions, but let's try to build something that at some point in the future will be ready to cut and to modularize, but when we face the problem that we need to scale. And we are going to do this using an example. And this example, let's say that we are assigned to create a conference management tool. And this is a particular example that I have chosen just because it's something that all of us here will probably have experience with, because we are either organizing a conference, or we are speaking at a conference, or we are just attending conferences. So all of us may have a different idea in our mind of what a conference management tool should have as features. But what we need to do is, let's forget about that. Let's forget about our own experience from the very beginning. We could, of course, add that in the conversation with our customers. But let's start by asking the different people involved in the different people that are asking us for the conference, for the tool, to tell us what the conference management tool should do. And it happens that if we speak to organizers, they will probably say that they are very interested in how the conference management tool is going to help them to organize the dates for an edition, or to organize all the relationship with the sponsors, or to set the call for papers in order to get the proposals from the speakers and decide and build the agenda and specify which talks are going to be part of the agenda. Also, they will be interested in managing how the tickets are going to be sold and how the attendees will register into the conference. On the other side, if we speak to probably the attendees will be probably interested being able to get the agenda and information about the speakers of our conference, and also to know how they could register or get their tickets to attend the conference. And finally, if we speak, for example, with the speakers will be probably more interested in knowing when the call for papers is going to open, how it's going to be solved, how will they be notified whether their talk was accepted or rejected, and this kind of thing. So different people will have different interactions with our system, and this is the first technique that we need to take into account. It's a technique called, I'm going just to name it, because you could find probably more information, and I will give you some links at the end of this session in order to know a little bit more about this. This technique is called event storming, and basically we are going to see the customer users in order to know how they are going to interact. We are going to extract a list of interactions with our applications. And once that we have that list of interactions, what we are going to do is we are going to apply the second technique. The second technique that is going to be useful is called CQRS, which basically means that we are going to start categorizing all those interactions into two types, those that are commands and those that are queries. This is the first step that we are going to take into trying to create some kind of modules or different categories for our system. And this means that we are going to somehow create two main entry points, or two main types of entry points, two main entrances to our application, those for commands and those for queries. So we need to identify what a command is. And a command is basically all those interactions from users that require that we are going to change, or we are going to need to change something in the data of our application. For example, let's say that if we get a new, we will have to add that proposal to the list of received proposals. So that means that we have another proposal more, and we need to change the state of our application. Of course, when we make changes in our application, some of these changes will be interesting to be notified to other parts of our system. But we will get back to that. So for now, we are going to focus on the fact that some kind of interactions require that we change data in our system. And these are the ones that we are going to consider commands. Example of commands in our conference management tool could be, for example, from the speakers. It could be to define the editions, or for papers, or to define a Q&A channel in order to make the attendees and the speaker able to interact and ask questions. If we speak to the speakers, probably some commands could be to submit a proposal, or to confirm the proposal once that it was accepted, or to join the Q&A channel in order to answer some questions from the audience. And from the audience, from the attendees, some commands could be like make any question or information about the rate of talk, or because commands basically mean that we are changing something in the backend, something in the information that we store for our application. On the other side, we will have queries. Queries means that are those kind of interactions that will basically require some information to be sent back to the user, but that information does not imply that we are going to change anything. So basically, queries are the requests from the users when they want to get some information back in order to check which is the state of the system. For example, there are some queries for the organizers that could be get me the list of proposals that I have received, or get me the popularity of this talk based on how many people want to attend that talk, because that way I could assign a bigger room for that talk or a smaller room for that talk based on that information. For the speakers, for example, some queries could be give me the questions that I have received after my talk, or the talk info, the info about my talk when I should speak, what do I need to do to connect, or what do I need to do in order to deliver my talk. And for the attendees, probably we will have, of course, give me the complete agenda, or give me the lists are in the Q&A session. So far, applying CQRS, we are, as I said before, we are in fact creating our first building blocks for modularizing our application. We don't need to create different artifacts. We don't need to create different projects. We just simply need, for example, to create different packages and identify that we are going to have commands on one side and queries on another side. So the next step is, how will we model the way that we are going to handle these commands and query requests? And for this, we are going to introduce the second technique that is going to be useful in our path, in our way of building application, which is DDD. DDD stands for domain-driven design, but basically what it allows us is to model our system paying attention to where the boundaries are. And those boundaries are really important, because these are the places that will allow us to split and cut our system into smaller modules in the future, when we need to scale and when we need to go to microservices. And if we are going to talk about how we are going to model our system, how we are going to model our commands and our queries, I want to start with this art. This is a drawing from a French artist. It's called Magritte. That it came to my attention when back in the years when I was studying at the university. It was the Darwin at the cover of a book about design, and it got my attention because I saw this pipe, and under the pipe I was reading this sentence that saying that wasn't a pipe, And I got puzzled because, of course, that is a pipe. But it happens to that this is not actually a pipe. It's the representation of a pipe. And that means that this is a model of a pipe, but a model that will serve to a purpose, which is I can get an idea of how a pipe is, of which is the shape of a pipe, or even which is the color of a particular pipe. But it's not a pipe, and I cannot see, for example, I cannot know which is the size of a pipe, because it depends on the way or the place that I represent this drawing, or which is the weight of a pipe, or how the pipe works internally, because I don't have all the information. This is just a representation, just a model that represents certain aspects of it, but not all of them. Another more useful example, for example, Kubernetes. This is basically a subway map in this from Munich, but basically a model. It represents all the lines of the subway transport system in Munich. But this is also a model of the same thing. And this, and this. Both, all of them representing exactly the subway transport of is which one would you prefer to use? And the response is a very usual one in the world of DDD. The response is depends. It's on what you are going to do. It depends on you. It depends, for example, if you are someone that are already living in Munich, you will probably use the first one because it's simple and it gives you enough information to know how to travel station to another. But let's say that you are need to buy a new ticket, and in order to decide which is the right ticket that you need to buy, you need to know which different or zones are the different stations that you are going to use station and ending. So the sec will be more useful for you. It adds information about the areas, the different zones. But if you are a tourist and you are interested in visiting the city, the third one will be probably more useful to you because it's adding some information about it and which are the closer stations to the places that you want to visit. Or if you are already in the city in a particular place, the last one, which is a Google Map screen capture, will be more useful because it will allow you to locate exactly the position in which you find the closer station to you. So basically, these are 4 different models, and each one of them having different kinds of information. The response is I should always try to use the model that is more simple, but gives me enough for the task that I want to do. Basically, the models should keep only the relevant information for presenting or for dealing with the action that we need to. In this, that means going to process different models on our system, and this is all of what is going to create this feeling of modularity inside our system. So what we will do is we will create a model to represent the different commands. We also will create another model to represent how we are going to deal with the queries. And that means in DDD, that's the command model and the projections. The projections basically are the way that we are going to represent the information so that it could be easily returned to the user, depending on the different requests that they have done. Let's see some examples in our system. We will have some actions. We are going to focus in this case in a particular feature, which is the Q&A tool, the Q&A chat room that we are going to create. So for example, we will probably identify that they have a command, which is the create chat room that is going to be issued mainly by the organizers, and this command will be modeled having only the minimum amount of information necessary to process that command. In this case, it could be just the name and the description of this talk. We will probably have also another command, which is the join room command, that will model the minimum amount of information necessary to process that command. In this case, it could be the user ID at the room ID that I want to join. Also, if I want to send a message, I will need the user, the room ID, and the message that I'm sending to that place. On the other side, the projections will be modeled differently, because we are going to have different models depending on what we want to represent. For example, for a query will be an example of a query could be get me the list of the different rooms that I have on my system, and then I will return a room, a description, and the number of members that we have on our system, on each one of the rooms. And we will have another command which could be get me the list of all the room messages. And in this case, we need to model information about the data that we are going to represent with those messages. Like, for example, the date and time that the message was sent, the user who sent that message, and the specific message that was sent. So these will be part of the projections. So far we have different models, one for the command, one for how we are going to represent the information that we will return to the users. But we also will need, and in DDD, the third element is called an aggregate. We will need a way to represent the information inside our system that will change when man sees that. Aggregate is being DDD, a set of objects or entities, and more importantly, the relationships that those objects have between them. But those relationships are also important because the relationship means that there are some kind of invariants that should be kept inside that relationship. So to explain this in another way, that we are going to define somehow the transaction on how a data chain should be applied, and in which moment we will consider all the chains finally applied. And these invariants are important because they will define the box in which the different objects, the different entities will be important for us. And these bonds are what are going to keep us having a place to cut later on and to create independent modules. So, but these aggregates shouldn't be a complete model of any entity in them. We need to keep in mind that they are just part of the domain, the part of the domain that we need to represent in order to deal with a request, with a particular request. For example, let's say in our Q&A tool, let's say that we are going to model the chat room, and the chat room will have an object with a name, a description, and probably a list of users. Though that list of a user in our system could be represented by far more information than just an ID and a name. But in order to model the relationship between the users and how they belong to a chat room, it's enough to know the ID and the name. And for example, in this case, we have two different entities that compose an aggregate, which is the chat room aggregate. In this case, there will be probably some invariants, like, for example, a particular user cannot be more than once in a chat room, or every chat room should have at least one admin. Those are the invariants that will give us the relationship between the different entities that we need to model in our system. So far we have this concept of modularity, like we have the commands and we have the queries, we have the projections to model the queries, and we have the command model to know how we are going to with the commands. But of course, because commands imply that we are going to change data, we will probably need to synchronize somehow the command model and the projections. This is what to next concept that I to introduce you that will be useful in order to build our modular monoliths that could scale to microservices. And this concept is called events. Events basically means that it's a representation of something that has happened. If you remember, our initial microservice architecture had a lot of modules that have dependencies, and these dependencies is what we are going to take a look into in order to identify which events are going to be useful to synchronize the different modules. Let's try to simplify our architecture, and let's pay attention to, for example, 4 modules in which one of these modules is something needs to update. Those changes will affect some other modules. And what we are going to do is we are going to cut these dependencies, and we are going to turn around the dependencies so that the module that is doing some changes is not going to call another modules. What it's going to do is going to create an event, and the interested in those changes will receive those events. So that way is how we are going to synchronize the model on one side and the model on the other module. And in order to identify which models are important to synchronize information, we will, which is called event model, is another step in this first technique that we talk about, which is event storming was a way to identify the different interactions that we have with our users. And event modeling basically means that we are going to identify the interactions that are required to do between the different modules, not from the users and our applications, but from the different module from our. And in this point, I would like to clarify 2 concepts that are sometimes used ambiguously, but they mean different things. Those 2 concepts are event and event sourcing. Let's start by saying what event streaming is. Event streaming is a way in which a module is going to using events or modules, and for that, what this user module is going to create, the module going to put that event in some kind of message broker will store all the events so that consumer enters the system and connects the message broker. He will receive all the different events that were produced. So this consumer will be able to notify and to update accordingly the different databases that they have. But in this case, if we see this consumer basically is just using the events to notify changes to another event, but the state application from the point of view of the consumer is stored on this local database. But what we are going to do, the alternative with event sourcing, is we are going to make also the consumer, we are going to get rid of this database, and we are going to make the consumer also add to the events that he has notified. So this means that event sourcing means that the real source of truth is not on our local repository, it's not on our local database, but on the events that we generated before. And why it's important to have event sourcing? Well, event sourcing, for example, is important because if we are used to use event streaming, or if we simply store the latest state of our system, all we will have is the latest information about something. For example, in this case, we could have a proposal, and we will see that we had a proposal John Doe that is basically withdrawn from our system. But we don't know why it was withdrawn, or if it was rejected, or what happened to this. But if we are using event sourcing, what we are going to store is what we have on the left. We will first, for example, we will have events identifying that the initial proposal draft was sent, so that we had just an initial ID. Then the proposal was updated, and we had a title and an author. And then the proposal was submitted. The organizers reviewed it and accepted the proposal, but it wasn't confirmed. But at some point, the speaker changed, and that speaker probably withdrawn finally the proposal. So if we are just using, if we are just storing the state, we will have the latest version of our data. But if we rely on event sourcing, at some point, we will have all the information of what happened before in our system. So at some point in the future, we will be able to identify more reasons on why we are in a certain state. For example, event sourcing will give us, for example, more information when we need to face an audit, or if we want to add new features, or if we want to do some data mining of what happened in the past. So these are really reasons to use event sourcing instead of event streaming. And finally, we have commands, we have queries, we have events, we have the different models. So we could probably be prepared to create some modular systems that could be converted to microservices. But we need to keep also another concept in mind, which is the location transparency in the way that we are going to build our application, and how we are going to notify these events from the command side and the query, and how we are going to send the commands to the different handlers or queries to the different handlers. There's another important aspect that we need to keep in mind. And this aspect is called location transparency. Because if we, what we are trying to do is just, we are trying to create an application which is a monolith with different modules inside. But at some point, probably identify that these modules is more complex, and so that we prefer to have a specific team working on that module. What we are going to do is we will be ready to extract that code into a different project, but at the same time, that code will be sending notifications to the rest of the systems. So that communication should be in a way that we don't need details on where that other component is. But on the other side, it may happen that another part of our system, for example, the system that is dealing with some queries, gets a lot of workload. So we also may want to extract that second module, and maybe we will need to scale by creating different instances of this different module. The important part here, as I was, is that we should be prepared so that all the communication between the different modules, when they are on the monolith, should not make any assumptions about the detail or the message broker that we are using to send queries. To also not know even how many other components are interested in receiving the notifications. So this is what we call location transparency. That means that a component does not know anything about other components in the system. They just send messages, and that will be applied to whoever, by whoever is interested in those. So how we are going to do this? Basically, the way to do this is by keeping independent the models. Instead of having one big diagram of entities and relationships, we will need to pay attention to those parts that correspond to different areas. And this is basically where the DDD and the boundaries between the different aggregates make sense, because those models will be independent, and those will be the parts that will be converted into events, those dependencies. And even it may allow us to, at some point when our system becomes more complex, to find different ways to split the model or to split an aggregate into different models, adding new events to our system. So basically, in order to keep the models independent, two very good techniques are CQRS and DDD. If we apply those, we will be ready to have independent models. But also, in order to achieve location transparency, we need to rely on the right tools in order to not make any assumptions on where other modules are located when we need to send those messages. And for this, because if we use event sourcing, because we want to have all that features that event sourcing allows us to have, we need to rely on an event store and a message bus. But the important part here is that not any message bus is enough to do event sourcing. We need to pay attention to event stores. And that means that at some point when we start a new module, that new module will probably be interested not in receiving all the events that have happened in the past, but only the events that will affect a certain aggregate ID. So an event store is just much more than just a message bus. An event store is some kind of specific database that allows us to retrieve events in certain order, also filtering the events that have a specific property, like a certain ID for the aggregate ID. So it's important to pay attention to the brokers and the middleware that we are going to use. And it's important to pay attention to the ability to store events and to read events in a particular way. So let's try to put together. Let's try to show some code. And in this case, we are going to model our application, our chat application for our conference management tool. And we are going to start by implementing the command model. This is a Kotlin application in which we are just creating the create room command. And the create room command is just using the right amount of information, which is the room ID and the name of the room command and the name of the room that we are going to create. But also in this case, we are using, the code that I'm going to show is using Axon Framework. Axon Framework is basically an open source framework that can be used on top, integrates very well with the Spring Boot, but is also useful for regular plain Java applications. So, but the thing is that Axon Framework is basically going to help us create these DDD CQRS applications with the location transparency inside. So in this case, we are going to specify using an Axon Framework notation that the room ID is the aggregate identifier. So that would be used to retrieve any previous events affecting that command. We also have the join room command, which is going to have the room ID and the participant that is joining. We will have the post message command with the room ID, the participant, and the message that we are going to send to the command, or we are going to the leave room command. So this is all the code that we need to implement the model. On the other side, we will have the event model. The event model will be those that are going to be used some changes in the system. They will be somehow linked to the kind of changes that we are doing from processing our command request. In this case, it's simple because we will have a room created event. That means that we are notifying the system that we have created a new room, and it will contain the minimum amount of information that represents the event. We will also have the participant join room event, the message posted event, and the participant left room event. On the query side, we will have, or before that, we will also have to have the model of how we are going to be modeling our aggregate, our entities in our system. And then we will have a chat room, which is an aggregate, which is from DDD. And we are going to have the aggregate identifier annotated to specify that that's the attribute that is going to be used to identify a particular example. So when we are going to add, how we are going to handle a command, we will add a command handler. This is an Action Framework command that will make the system invoke this constructor whenever we receive a create room command. The important thing that we need to do here, if we want to apply event sourcing, is that we should not change the state directly when we are when we are receiving the command. What we are going to do is we are going to create an event and we are going to notify that event. Similarly, we will have another command handler for the rest of the commands that we are going to receive that affects that we need to change the state of our aggregate. In the case of our handlers, we'll always send the right event to the system. The thing is that, as I was saying before, our producer, in this case, the command handler, will also react to the events that they are sending. So what we are going to do in this case, whenever we receive a join room command, we are going to send the event saying that the participant joined the room, and we are going to add another handler, which is an event sourcing handler on our model, in order to change the state of our aggregate. In this case, in the event sourcing handler, we will add the participant to the list, to the set of the participants of this room. This is very useful because once that we have, if we need to start another instance of this module in the future, this module will create a new aggregate and will connect to the event store and will get not the commands, because the commands already happen, but they will receive all the events. So what we need to be prepared is to react to the participant join room event in order to recreate the state of our aggregate. Also, it's important that the command validate, we need the command, but not the events, because the events already happen. We cannot reject to process an event. That event already happened. But we can validate that the command is not valid, or if it's not valid, to create another event. Finally, in order to sync with another components, for example, on the query model, we will have, for example, the projection that is going to have all the information for the query request. And in this case, we will also have some event handlers that will update accordingly their own model based on the notifications that were received from other parts of the system. Finally, the query handler will basically just query the internal model that we have. The projection will simply send back the information that we have in our model. So in summary, and in order to conclude our talk, basically, don't try to just apply the blueprints and practices that others apply. Just try not to follow hype-driven development. Try to pay attention in your next project to all the things that fall to arrive to a particular architecture. So it's always important to think what's the path and not final solution. Finally, if you learn a little bit more about all this content, I have prepared for you a page in which I'm going to have all the information about all the related information about all these concepts that I have spoken in this talk. You will have the slides. have you will see a GitHub repo with some code samples and some useful information. These code samples will allow you to also follow a tutorial in order to apply yourself the same concept that I have seen, and try the same to the same modular monolith. And at some point, you will also be able to split that monolith into different components that will interact between them. We also have created an academy which contains so far a couple of free DDD, CQRS, and Event-Sourcing courses. We also have some information on the open source framework that we have created, and some message broker and server, which is an event store, and a message broker, which is called Action Server, and some other action tools that are useful in order to build your monoliths. Also information about event modeling and event storming. And a very good recommendation is to read the Domain-Driven Design. It's an old book, but it's really a good one. So you can just go there and click on the links and have much information. I will also publish this URL on the chat and also on Twitter. If you follow me on Twitter, I will publish information. And yeah, if you follow this, and if you have any questions, ping me, and I will be more than happy to help. I don't know if we have questions or if we have more time to solve any of those.
David, thank you. Thank you for your talk. It was amazing.
Thank you.